Good afternoon. I'm Keith Holliday. I'm the CEO and one of the founders of a company called Global Drilling Sport, not Solutions, but that's okay. What we do is we manufacture top drives. And for those of you who aren't familiar, I'll go into a little bit more of what a top drive is. But it's a piece of drilling equipment. Our customers are typically the drilling contractors who in turn work for the oil companies. We design and build our own top drives, and we also repair and service our competitors' top drives. We also do training, spare parts, and so we consider ourselves experts in kind of top drive business. What's a top drive? A top drive is that big yellow thing kind of towards the top of the screen. It's a large electric motor in most cases now. So some of the older ones were hydraulic, ranging from 200 to 1,500 horsepower, and it drives the drill bit. So it's kind of the heart of the oil and gas drilling rig. When it fails, the rig cannot produce, the rig cannot continue to drill, and hanging from the top drive are a lot of accessories or robotics that help handle pipe and bring the pipe in and out, and that's kind of what a top drive does. Top drives have a maintenance element to them that's pretty important. Probably the biggest piece of maintenance is that most people follow with their top drives is API, American Petroleum Institute. And what they say is every 5 years or whenever the OEM recommends, you need to tear it down completely and inspect it because it's working overhead of everybody. So it's a bit of a safety concern. 5 years is just a date on a calendar from start to finish. So what we wanted to do was try and put a little more intelligence to that and help our operators understand when it really needed to be done. Maybe it was 3 years, maybe it was 10 years. We sort of back into the calculation of the main bearing in order to determine that. And depending on the drilling operation, that sees some amount of use or is really abused or not hardly used at all. Another aspect is the safety standpoint. As I said, it hangs overhead. So if we're able to look at things like vibration or the drilling conditions, we can understand how much maintenance we need to put into it. And then the downtime is the customers expect these things to be extremely reliable. They're in place during the whole well drilling program, but there is plenty of opportunity in order to service them. But they're not easy to service. They're hanging overhead. A person has to either get in a basket or get in some sort of lifting device in order to go up and do it. And then also there's a cost to maintaining them even when they're not operating. Like now, when the rig count is so low here in the U.S., there's these pieces of equipment that are sitting idle, and they also need maintenance.
Is that what cold stack means?
Yeah. So what was our challenge? We have lots of units out in the field. We're fairly new to being a top drive manufacturer. We have about 50 units. We have them from Nigeria to the U.S., several down in Mexico. They're all over the place. They're onshore, they're offshore. Some of them have internet connection, some of them have 3G signal. We had the information available to it. We use a Siemens PLC where all of our sensors sort of go into. Most of our competitors are still sending their signals down kind of on a single wire just to an operator's panel. So we have a PLC. We knew the information when we lived in that PLC. When we were on site, we could get some of that information through our hard drive or through some data we were collecting. But we didn't have a way to get it somewhere where we could really manage it in bulk and really have a good look at all that data, not only for our equipment, but our competitors' equipment as well. So we looked at doing a kind of a homegrown solution, and most of our competitors, that's the route they went. But we realized we didn't have the people in-house in order to understand the industrial internet and get it off the machine and to somewhere where we could use it, and particularly into a platform that we could commercialize on, where our customers could see value rather quickly. So the top drive is there to the right, and what we wanted to do is get a continuous flow of data off of the top drive into the cloud in order so we could look at operating statistics and performance management. Our customers knew that that's what they wanted as well, but I think we're still a little bit in the infancy stages. They know they want the data. They're not sure how powerful the data is yet, but they want to start to analyze it and see why their equipment goes down. Do their operators require more training? Is it an engineering change we could make to the machine? Just what exactly we need to do. So the solution that we chose was coming out of our PLC. We go into this product that GE offers called Insight, and we go into a field agent that connects either wirelessly through a 3G signal or through the internet, and it takes that data out of our PLC and it puts it up in the cloud. Then there's also a canned application that either us or our customers can go into, and they can manage that data. They can look at it, they can set alarms for themselves, and then start to collect it. By doing that, as I said before, it prevented us from having to have a whole group of IT people and learn a bunch of things we weren't good at. We were good at building top drives, good at building machines, but not necessarily experts at getting that data to our customers. So this is kind of an example of how it worked. The top drive is there to the left, the controller being our PLC, goes into this field agent to which you communicate the data, the sensors, whether it be on or off, ambient temperature, whatever we're monitoring, and then it can come back to the end user, which could be the oil company in this case. They could be interested in the vibration sensor on the top drive on how the well is being drilled, the OEM, which is us, so we can make our product better, and able to analyze the data, make our machines more reliable, and really give our customers some solid data as to why our equipment's better than our competitors and what we've done in order to make it more reliable. Of course, to their field service personnel and ours as well, so we can actually get a call when it's time to show up there with a filter or perform maintenance in the future. And then to their mobile operators as well, so at the touch of a button or even on their cell phones, they can see what that top drive's doing at any particular time, whether it's up or whether it's down. Things we're managing, and how we went about this, we looked at all the things that we could monitor, and I think coming out of our PLC, we had hundreds of tags, either alarms or sensors that we could monitor. We really didn't want to boil the ocean. We felt like that was a mistake that some of our competitors done, is looked at a little bit too much. So although we're recording all of that information, we're bringing to the forefront some of the major KPIs that we thought were important: vibration, temperature, torque, pressures, and then really looking at the key indicators that we knew would make, that if we monitored, we could make a significant impact pretty quickly. What we did is we installed 2 field agents into 2 units that we have working in the Marcellus Shale. At first we connected to the internet, but we found that was difficult because the rigs were continually moving and that required some setup. So this product has a way to connect a 3G signal. So we opted to do that. So now whether the unit is moving, idle, or straight, we can stream the data across. We can look at it, and we can look at helping our customers understand how to best utilize the machine. It also gives us quick visibility for things like warranty, where we're looking at the vibration and saying, you know, you're now operating this equipment outside of its design parameters. And we've seen a lot of that. We've got units that are operating in Saudi Arabia, drilling a surface hole, the beginning portion where the hole is very large, and seeing in excess of 10 Gs where API's design criteria is 2 Gs. And either it's holding up or it's not, but till this point nobody's had a point of reference, and nobody certainly had a point of reference that they could look at on their cell phone kind of in real time and say, rather than have someone's opinion, this sure looks really hard, or you know, it should hold up type of thing, rather than just, you know, sticking your finger out there and saying that. So the 2 pilot units are running now. It was relatively little or really no upfront cost to us to get the pilot units up and running. And then it's a monthly subscription we pay, which is pretty reasonable and pretty easy to pass through to our customers. What we're hoping to get out of this, we hope to have competitive advantages over our competitors. In my business, our competitors are huge companies compared to us, billion-dollar companies. We're 130 or so employees and started in 2008. So looking at this stuff, what they've done is they've had products that were designed sort of 20 years ago, and they continually sort of upgrade them. And what gave us an opportunity, I think, to be ahead of them is to just step back and have a look at the overall design and what other industries have done, and really put a PLC right on the machine where we can communicate many more sensors on either an Ethernet cable or a wireless connection between the top drive and the control house to the brain, the PLC. And then once it's in that PLC, do whatever we want with it, using this platform to get it up into the cloud, and then allowing our customers access so they can put it into their SAP systems or their computerized maintenance systems. And it's we're still in the infancy stages, but that's starting to work for us. And what we find with our customers, they know they want the data, but I don't think they know yet what to do with it. They're kind of sitting in a room like we are, saying, all right, now that I have it, now how do I apply the analytics to it to understand how to really make my machine more reliable? It also gives us a revenue stream for remote monitoring. Some clients just really want you to sit there and watch that machine, or at least take a look at it 2 or 3 times a day and say, everything looks fine, you know, keep on, or you may have a problem, let's schedule a service call. It's opened up a bit more of a justification for maintenance service contracts. We have a couple of clients in remote locations in Saudi Arabia again, where we have technicians that visit the rigs every couple of weeks and just do a health check and inspection, check all these data points, and make sure that everything's doing. But that could possibly go away if we can get these systems online and we can just go in and check them remotely. And it'll help us improve the machine design. We were talking just today at lunch. As I said, the machines were designed 20 years ago, and the easy thing to say is they require more torque today than they once did. So that just means that everything below it has gotten stronger, that the top drive can now put more torque into the pipe. But we use them completely different than they were originally designed for. They were designed to drill a hole like you would take a Black & Decker drill and drill through a piece of wood. Now we have directional drilling tools where most of the work's being done by the hydraulics of the mud that's being pumped down through. So they're hardly seeing any rotation at all. So with this data, we'll back into I mentioned that 5-year calculation. That's based on the bearing life, the main thrust bearing inside of the gearbox. We can back into that calculation and say, you know, maybe that number can be 10 years. And in an environment like today, where the operators are telling our customers they can have 1 or 2 wells to drill rather than when the market was good and they would require a 5-year contract, if they're looking at a capital investment because that time frame said 5 years, they can't afford to put that piece of equipment back to work. So it gives them a competitive advantage in order to push the maintenance cycle out. From a service differentiator, our customers see that we're being proactive and looking at their equipment, and rather than just focusing on our aftermarket spare parts and saying that business is good, really looking at what's failing and why it's failing and trying to make the product better. And I think eventually it'll open up a potential revenue generator for us, so depending on how deep we want to get into the condition monitoring with it. Additional opportunities. This is a layout of a typical drilling rig. This is the drilling rig that the field agents installed on in the Marcellus Shale. It's a smaller company. It's called Orion Drilling. They have about 25 of these rigs. And it's these smaller guys that are able to keep their contracts, it seems to me, through these slow times. So they're about 75% utilized despite the North American rig count. The top drive's that big heart right there, number 1 in the middle. We're connected up to that through the PLC, but what the customers are asking for is, can you start to connect some of my other pieces of equipment? And they've tried to do that before, and sometimes have tried to do a bit too much. I can recall one customer telling me a story how he tried to do his drawworks, which is number 2, which is just a big winch, and he had like I think he said 120 sensors installed on it, and it was $30,000 or $40,000. And when they got it to its data point, our PLC in our case, they could never get it off the rig, the information. So they wasted a bunch of money and never really got anything out of it. So what I've been proposing to them is 5 or 6 points on these key pieces of equipment. Number 3 is the Caterpillar engines. They've got a certain amount of data that you can plug in and get without even getting their I think it's called the ET system, but tie all those together into this one field agent and then get it off the rig and into the cloud where they can analyze it. And I think we can charge a monthly fee for that. And then I guess after gathering the data, we can start to look at the analytics of it and really start to build some IP around preventative maintenance, and particularly in this environment. That was it. Thank you.